This is Algebra 1, Lesson 9.1, Part 2, where we're solving radical equations. Part 2, after example number 3, we have these few problems to do on the back. So everybody copy this one down right here. X squared is equal to 16. Remember that in order to undo squaring something, you take the square root of it. If you take the square root of one side, you always do the same thing to the other side, and that's going to give you what x is. So right there, to get x by itself, just like we normally do, if we draw the line, we want it to say x equals. We don't want it to say x squared equals. So in order to get rid of x squared, we take the square root. That will cancel it out and leave us with just x. That's what we were trying to get. When you take the square root of one side, however, you have to do the same to the other side. The square root of 16 means what number times itself is 16. We know that that's the number 4, and it's both positive and negative 4. Below that one or next to that one, do this. Take about 20 seconds. So again, to get x by itself, to get rid of x squared, you're going to take the square root of both sides. If you take the square root here, it cancels it. You take the square root of here, you get the square root of 11. So now x is equal to, unlike 16 though, 11 is not a perfect square, but it is both the positive and negative version of the square root of 11. This is all we do with this. It's just like having a radical expression. I'm sorry, it's just like having a variable expression. We don't try to simplify it to the decimal equivalent. What about x squared is equal to negative 4? Take about 20 seconds, see if you can figure out what x is. So again, we're going to follow the same process. In order to get x by itself, you undo x squared by taking the square root of it. That's why we learn the process to where we can go straight through to what we do know to find out what we don't know. That will cancel out x squared and leaves us with just x. If we take the square root of one side, we must take the square root of the other side. Now what this is saying is what number times itself is negative 4. If you multiply 2 times 2, you get 4. If you multiply negative 2 times negative 2, you get 4. There is no number that when you multiply it by itself that gives you a negative value. Or let me restate that there's no real number. You'll learn about complex numbers in a later course. But x's value is no solution for this one. And what about x squared equals 100? Take 10 seconds on that one. Take 10 seconds on it because that's about as long as it takes. Again, get rid of x squared. Practice the procedure by taking the square root. When you do it there, do it here. The square root of 100 is 10. And again, we know it's the positive and negative version of 10. As simple as that. That's when you have x squared all by itself. If it is not by itself, we got to get it by itself, and we got to follow our order of operations. And that's where example number 4 comes in. It says rewriting before finding square roots. So this one does not have x squared all by itself. It has 5 times x squared, and then it says minus 20. So order of operations, we learned it is one of the first things we learned in this class, and you knew it before you ever walked in. It was parentheses, then exponents, then multiplication and division, and then addition and subtraction. What we learned, what we expanded on with that in this class is we talked about inverse operations. We said in order to undo addition, you subtract. In order to undo multiplication, you divide, and vice versa for both of those. In order to undo subtraction, you add, and in order to undo division, you multiply. What I'm adding to this order of operations now is in order to undo exponents, you use radicals. And in order to undo radicals, you use exponents. We will focus on the number 2 in this class because we'll talk about things being squared. In the next class, you'll get to the third degree and so on and so forth with future classes. But your order of operations does not change. When you undo things, you work backwards. So right here, we have 5x squared minus 20 is equal to 100. You undo any addition and subtraction you see. So it says minus 20. You undo that by adding 20 to both sides. 0 plus 20 is 20. So then there's no more addition and subtraction. Now you have 5 times x squared is equal to 20. So you go to the next step, multiplication and division. In order to undo 5 times x squared, you know you divide both sides by 5. That will cancel out times 5. And that leaves you with x squared is equal to 4. Now it looks exactly like the problems we just finished doing. You go to the last step that we will deal with in our order of operations priorities, exponents slash radicals. You undo x squared by taking the square root of both sides. The square root of 4 is both positive and negative the square root of 4, which is positive and negative 2, since it is a perfect square. Very simple. Order of operations backwards. Take care of addition, subtraction, then multiplication, division, then exponents and radicals. Another example to go along with this one on the back, everybody, 120 minus 6x squared is equal to negative 30. Remember your order of operations, work it backwards to undo it. Okay, let's take a look at it. We got 120 minus 6x squared is equal to negative 30. Undo addition and subtraction first. Order of operations. It says 120 minus 6x squared. That means addition and subtraction is happening between them. The fact that it says positive 120 tells you how to undo it, though. You subtract 120. When you subtract it on the left, you subtract 120 on the right. Those are the same signs, so we got to add them up. 30 and 120 is 150. And you keep that common sign negative. The 120 is eliminated on the left, and you're left with negative 6x squared. So there's no more addition and subtraction happening. So we're past that step on our priority list. Now we go down to multiplication and division. We go down to multiplication and division. It says negative 6 times x squared. You undo times negative 6 by dividing by negative 6. When you do it to the left side, you got to do the same to the right side. A negative divided by a negative is going to be a positive. You might not know what 150 divided by 6 is, but think about 6 quarters going into $1.50. So x squared is left on the left equals a negative divided by negative again is a positive. 25 is 150 divided by 6. So then we got one more step. There's no more multiplication and division to take care of. So we'll go to the last step, undoing our exponents slash radicals. That's what we're adding to it today, the radicals part. So get rid of x squared by taking the square root. If you do it to one side, you must do it to the other side. Remember, this cancels it and leaves you with x. That's what we were aiming for. The square root is 5, and remember, it's both positive and negative 5. So if you plug in the number 5 in place of x, you'll see that you get a true statement. 5 squared is 25. 25 times negative 6 is negative 150, and 100 minus 150 is negative 30. Same thing with negative 5. Negative 5 squared is again 25, and then it's the same operation for the rest of it. So both positive and negative 5 will make yourself have a true statement here. Then we have 3 checkpoint problems, 3 I believe. Yep, 3 checkpoint problems says solve the equation or write no solution. X squared is equal to 11. In order to get x by itself, you need to undo squared by taking the square root. The square root of 11 is not no solution if you thought that at first. There is a real number that when you multiply it by itself gives you 11. It is just an irrational number. It's not a perfect square. The only ones that have no real solution are the ones that have a negative inside of the radical. Number 8 says 3x squared minus 75 is equal to 0. Again, undo your order of operations. Undo minus 75 by adding 75 to both sides. That leaves you with 3x squared equals 75. Then undo 3 times x squared by dividing by 3 on both sides. That leaves you with x squared equals 75 divided by 3 is 25. Then get rid of x squared by taking the square root of both sides. The square root of 25 is both positive and negative 5. You'll notice with these types of problems that the same numbers keep popping up over and over again. That's not a coincidence. It's to where you can focus on a procedure instead of the arithmetic of ridiculous numbers. 2x squared minus 22 equals 50. Undo first, you have to undo the fact that it says minus 22 by adding 22 to both sides. That leaves you with 2x squared is equal to 72. Now it says 2 times x squared. Undo times 2 by dividing by 2 on both sides. X squared now is equal to 36. Undo x squared by taking the square root of both sides. And x is now equal to both positive and negative 6. Again, those last two problems were perfect squares, unlike 11 for number 7 was not a perfect square. That's why it stayed as a radical for that one.